are your thoughts on solving that? So if you're able to see the screen and hear me, somebody could just message on the chat. And so these two questions are the recent question that was asked in the Turing test. I will be sharing the link again so that the people who have joined recently can see it. So this is the URL for the two questions. So somebody asked if they give the same questions to everyone. So no, they do not give the same questions. The questions are different, but they repeat a lot. So the two questions that you are seeing on my GitHub profile page, they are like from a recent final coding challenge. So final coding challenge in the Turing, if you have already applied to, that will be the final round after you clear the tech stack test. And generally Turing coding challenge is easier as compared to other coding challenges, but the only thing is they give only 30 minutes to solve two questions. So if you're not quick, it can become sometimes challenging. So I will be sharing the solution to them in Java, and before writing the code I will also describe the steps or the algorithm that you can use how to solve that question. And the questions are not that difficult, and it should be very easy to convert the algorithm or the pseudocode into any language. And I will be showing you the Java language for now, and later on after our meetup ends today, I will be posting the code for the same in JavaScript and Python as well, but they should be fairly straightforward to convert into JavaScript and Python. So if you have any other questions, you can ask right now. I think some people may join in a few minutes, or if you have any ideas how to go about solving these two, you can message in the chat box, and then I can start. I will start in like 5 minutes if you don't have any questions, and I will give you the approach to solve. So I think only one person has asked the questions. So yeah, they repeat a lot. That's what is important. So there is a high chance that if you are giving this interview, I mean, at least 50% of you will see one of these two questions for sure. So don't use the solution that I'm giving. That could cause trouble, because if you get the same question and if all of you just simply use the solution that I will be showing today, that could cause some trouble, because they may detect that you have copy pasted it from somewhere. So that's why it's important you can use it, but try to modify it and use it and make it your own, and that will be much better. So these are from the final round coding challenges. Okay, so first I think I will go about discussing this finding max depth question. So I will open this in my IntelliJ. So this was again one of the questions that was asked in the Turing coding challenge round, and let's try to enlarge it. Okay, so anyone has any idea or approach how to solve this, you can just message me. That will become a little bit more interactive, and because if you have already seen this kind of question, it should be easy. If not, then it could be a little bit difficult. So the question, I will also share a Google Code Jamboard link. Let me know if everyone is able to view that. It might be helpful for me to. It might be helpful to explain the solution to this and that question. So once you open the Jamboard, you should see a binary tree in the Jamboard, and so basic idea is like in this question, what it's basically saying is you have to find the maximum depth of the tree. So basically you keep on going down, and when you reach a leaf, that is one depth. So I will share the code jam link, and I will try to do so here. So like if you're given a binary tree here, the idea is to find the maximum depth of the binary tree. So you can use DFS to do that, but DFS sounds like I will say a big thing. In this case, you don't need to go that complex. So in this, for example, what question is saying is, so like this is the root node. If you are able to see my cursor, so this is the root node, and now there is let's see all the paths that are possible from the root nodes to a leaf node. So from the 1, I can take a path from 1 to 3. So this is one path from root to leaf. And let's see how they define. So they define the depth as the number of nodes on the path. So if I take this path on the binary tree from 1 to 3, the number of nodes in this path is 2. Okay, so there are several paths that I can take from the root to the leaf. So this is one possible path, 1 to 2 and 2 to 6. The number of nodes in this is 3. This is one possible path. So in this also the number of nodes is 3. So the maximum of all these is 3. So like so there are actually 3 possible paths, one this, and one this. And this has length 2, depth 2, this has depth 3, this has depth 3. So maximum of 2, 3, 3 is 3. So the answer is 3 for in this case. I will take one more example if you didn't get what I'm trying to say here. So yeah, this will be a good example. So people who are doing it first time, it will be a good example to actually see this image, and maybe somebody could, if you want, like let's look at this tree, TH or whatever this is, TB. So what do you think what do you think will be the output for this particular tree? If I just look at this particular tree, the TH, so what do you think will be the maximum depth of this particular tree? If somebody could answer, then it will be a little bit easier for me that everyone is able to understand. Yeah, it will be 7. So basically we have to consider only that path which has the maximum number of nodes. So in this it will be fairly simple. So it's not the number of edges, it's the number of nodes. That's why it's 7, not 6. So here I can just take this particular path, and that's the answer. So because this particular path has 7 nodes. So yeah, so I think that's clear to many people. If it's not clear to somebody, you can just message me in the chat box. I will try to explain here why it's 7. And similarly in this, if I consider the maximum, the longest path will be this, which is having 1, 2, 3, 4, 5, 6. So in T1 it should be 6. 1, 2, 3, 4, 5, 6. So this path is the one that has the maximum depth. So if I give this tree 2, 3, 4, so the answer should be 4. In this, the maximum path, the path with the maximum depth from the root to the leaf has 4 nodes. So the answer should be 4. So if this idea is clear to you, then it should be pretty. The question now becomes, how do you find this maximum path? So you don't need to do, although DFS is also a correct answer, but you don't need to think of that complex. This can be solved using very, very simple recursion, and you just need 2 or 3 lines of code actually to solve it. So now let's look at this particular graph, or let's look at this T2. So suppose I want to solve this for T2. So the idea is to use recursion. Once you think of using recursion, this question becomes very, very simple. So if I look at, suppose I want to code, I am given this tree and I am given this root node of the tree, and I want to find the maximum depth for this particular tree, then I can do it. So this is not a binary tree, but for example we can consider it because this has 3 things going in here. Or for the sake of this question, let's take a look at T1, because this T2 is not a binary tree, so this is not a valid example for this particular question. So if we see this, so this is the root node, and now we can either go from each node, we can either go left. Okay, here also the example is little bit corrupted. Let me use a different image which is shows much better, which is actually a binary tree. So okay, now this is a perfect binary tree. So the idea is that you are given this root node and you have to find the maximum depth of the binary tree. The way you use recursion is, so consider any path that is the longest path. So in this case, like this is also the longest and this is also the longest. So consider any path that is the longest. That longest path will either be on the left hand side or on the right hand side. So what I can do is I can go towards the left hand side of this node and find the max depth in this tree, in this subtree, and I can go to the right side of this subtree and I can find the max depth of this subtree. So the max depth of this subtree is 2, because either this path also has length 2, this path also has length 2. So in this particular case, both the paths have length 2. So if I calculate the max depth of this particular tree, the answer is 2. And if I calculate the max depth of this, the answer is 1. Now to calculate the max depth of the main node, this root node or the whole tree, once I have the max depth of the left subtree and the right subtree, I just have to take the maximum of these two, which in this case is 2, and add 1 to it. So once I do that, maximum of this one and this one is 2, because this is the max depth for this is 2, and then I add 1 to this, and that gives me 3, and which is correct answer because the number of nodes on the path is 3. Why that works is because any path that so has the max, so if suppose this I have the left subtree and I have the right subtree, and suppose if the left subtree is the one that is maximum, then there is exactly one edge coming from this particular subtree to the root node. So I just need to add, so any longest path in this subtree, whatever, so if this subtree was more longer, any longest path to this subtree, I can create a longest path or the maximum depth to in this particular tree by just adding this particular one edge. So if I add this one edge to the longest path in this particular subtree, that will give me a longest path in the whole tree. So the answer, that's why it is 1 plus and whatever is the length of path in this particular subtree, because this is the maximum one. In this case this is 1, so it does not, we will discard it. And the way to code is, I will show how we can. Okay, so this tree node class, you don't have to implement this tree node class. This is already given to you in the coding challenge, so you just have to focus on implementing the, but I will just write it how it is actually given. So this class is already given to you and you are just supposed to implement this function. And the idea is to use recursion, and as I told that we actually find out the max depth of the left tree. We use the same logic and we find out the max depth of the right tree, and we take the maximum of this and we just add 1. So it's actually just a one-liner. Apart from that, you just have to specify the base condition in this. So here I can do for the base condition, if root is equal to null, I can just return 0. So in this particular case, that's all. That's actually a submittable solution. So this is a working solution to actually this. So there is nothing much. The only thing you have to remember is the idea about the algorithm that we use. If you understand this, then it's fairly easy to write in any other language. So the idea is just basically calculate the max depth of left subtree, calculate the max depth of the right subtree, and then you just return 1 plus max of the value and returned in 1 and 2. So you can actually code it in easily in any language. It's in JavaScript or Python. This looks almost exactly like this once you understand the solution. So there is nothing much in it. So anyone has any doubts on this particular question? How to, like, does it make sense, this question? We can also run over some examples, but it will be difficult to create a tree practically, but I will try to create a tree. Let's create a root node. So root node, the value anyway does not matter, so I can give it as 1. So I will try to create a tree which I actually messaged earlier. Let's see if I can share. So which constraints are you talking about, like the time constraints or some other constraint? In this question, let's look at the time complexity. So this question actually works, so there is not, time complexity is not much in this question. Unless you are using a solution that takes a lot of time, that could cause trouble. But in most of the things, you only need to take care of, I will say, not many things. You only need to take care of the edge cases. So edge cases like this kind of things, like when the root is null, what do you do? And the second is algorithm efficiency. Although in Turing, I have found it's not like other programming challenges. The efficiency, even if it's not very efficient, they still accept the solution and they select you. So constraint. So when somebody asks constraint like maximum size or R or maximum value. So the idea behind giving a large value is that they want to time out your solution. So let's look at the complexity, time complexity of this solution. So you don't need anything special to handle large value. If your time complexity for the solution is good enough, that's good enough. So like if there are n nodes, and so basically if you see how in this particular case how it will go, so it can be depending upon how many nodes are there in the left nodes, it will take that much complexity. Let's write it in this format. It makes more sense. You don't need anything special to handle constraint. This is a working solution and an accepted solution. Okay. So I just want to find. So if I give a t root, how many steps do this recursive solution takes? Okay. So it will take actually this many number of steps, because how much time it takes to calculate the left value and how much time it takes to calculate the right value. And actually if you see, I can expand this to, so to calculate the root of left, I can again take root dot left plus 2 dot root dot left dot right. And here I can do root dot right. This may look little complex if I'm not used to writing time complexity. Root dot right. So if you see each time, so first time there was a 1 here, the next time there are 2 more ones that are getting added to this. Okay, and not only 2 more ones are getting added to it, so each time a 1 gets added to it, I'm moving more down to the tree. I'm going more downwards to this. So it's like I'm at the root, then I go to then I add 1 and go to the child nodes, and then I add 1 more and go to the child nodes. So each time I go 1 level down, there is a 1 that is added. And let's see what happens here. Max step, max root. So I need to calculate this one and then this one step. So the number of steps to calculate this will be 1 plus this. The number of steps to calculate this will be 1 plus this. So each time I'm going down, I'm adding 1, and the amount of time that I can go down is only till the depth of the tree. So I cannot, so this particular extension, this kind of thing cannot continue. So like suppose if the max depth of a tree is k, then after k such steps I will have something like this: left dot right dot left something. And if there are like k entries here, then I will definitely reach a leaf node, and that will give me an output of 0, because I will, after leaf I will get a null, and because leaf dot left will be null and leaf dot right is null. So by leaf I mean a node that does not have any children. So yeah, so this will be actually equal to 0, this kind of thing, and at each step a 1 will be added. So in terms of n, this looks a little complex equation. Let's see if we can simplify it. But I think it's a linear solution. So let's consider a tree which has just 3 nodes. Okay, so like there is a root node and there is a left child and there is a right child. So suppose the tree is like that, and then if I calculate the t of the leaf nodes, they all will give me 1. And so one step for calculating the left hand side and one step for calculating the right hand side. So I have one step for each of these leaves, and then one step to calculate the maximum of both, and one step to calculate one. So this is the number of steps taken to calculate the depth of the tree. Which is equal to 4. So it's like it seems it's like twice the number of so the max step node in this case is n. So the node that gives you the max path is any node. Like you have a tree like this. On the left side there is 2, and on the right side we have 3. So this is the tree I'm talking about here. So this tree, the answer for this will be 2, and number of steps will be equal to 4. So maybe we can prove through some logic that if a tree has max depth is equal to k, then number of and the tree has n nodes, then we can probably find the number of steps is equal to number of steps to calculate the max depth. Maybe we can find some formula according to this, because each node will be visited at most once, so this number of steps will definitely be greater than n, because we will be in the algorithm, we will be finding out the maximum value for each subtree. For each node we will be going towards each node and finding out what will be the maximum value of this tree, and once we have got the maximum value of maximum depth of a particular subtree, and then we will be basically using that maximum value to store this value in the recursion. So this is a bit complicated equation, but my guess is that you can do it in order n time, where n is the number of nodes in the tree, because at most you will be, idea is that at most you will be visiting a node one time, and once you visit a node you can actually calculate its depth immediately once all the depth of all the nodes that are children to that node is already there. So one observation is that you can calculate the depth of a node or subtree in 2 additional steps. Once determine the depth of all nodes in the child tree. Because once I have determined all the nodes of the child in the child tree, I just need to basically take the maximum of both and add one. So we can skip this part as of now, because this will become more mathematical, and this will lead to much more kind of proof kind of things. But this code works, and this works well, and this does not take much time.